Good morning, everyone. I welcome you again to the lecture series of object-oriented programming using C++. Today, we'll be going to discuss yet another topic of object-oriented programming, which is generic programming. These are the list of topics to be covered in today's lecture: template, template functions, and overloading of template function. So what do you understand by generic programming? It is the style of computer programming in which algorithms are written in terms of types to be specified later that are then instantiated when needed for specific types provided as parameters. For example, classes like array, map, etc., which can be used using generics very efficiently. The method of generic programming is implemented to increase the efficiency of the code. Generic programming enables the programmer to write a general algorithm which will work with all data types. C++ uses templates to enable generic programming techniques. Templates in C++ may also be used for template meta programming, which is a way of pre-evaluating some of the code at compile time rather than runtime. Using template specialization, C++ templates are considered Turing complete. Templates are powerful features of C++, which allows us to write generic programs. In simple terms, we can create a single function or a class to work with different data types using templates. Templates are often used in larger code base for the purpose of code reusability and flexibility of the programs. Template classes are known to be generic classes because those can be used for any data type value, and the same class can be used for all the variables of different data types. A generic type is a generic class or interface that is parameterized over types. Rather than specifying object to be of an int type or a string type or any other type, we define a class to accept a type parameter t. So when should you use templates? We use a template in a base or composition when you want to retain type safety or would like to avoid virtual dispatch. Templates are appropriate when defining an interface that works on multiple types of unrelated objects. They are the function templates and class templates are the two categories of templates. The compiler can determine at compile time whether the type associated with the template definition can perform all of the functions required by that template definition. C++ templates are often misunderstood, misused, or overused. It is used when a non-template approach would be just as good and easier to use and easier to read. They are also frequently avoided due to lack of understanding. The use of C++ templates does not imply poor design. A template is a simple and yet very powerful tool in C++. The simple idea is to pass data type as a parameter so that we don't need to write the same code for different data types. For example, a software company may need sort for different data types. Rather than writing and maintaining the multiple codes, we can write one sort and pass data type as a parameter. C++ adds two new keywords to support templates: template and type name. These are the two keywords. The second keyword can also be replaced by keyword class. So how templates work? They are expanded at compiler time. This is like macros. The difference is compiler does type checking before template expansion. The idea is simple. Source code contains only functions, but compiled code may contain multiple copies of same function or class. This is the example of template. The type name is T. The name of the function is myMax. The two parameters are X and Y. The return value is if X is greater than Y, you have to return X, otherwise Y. So in the main function, you can see the calling part as well. You have to call the function myMax, then you have to give the parameters, whether it is integer or character or float. Then you have to pass two parameters like 3,7 in case of integer. And if you put the data type as character, then you have to pass parameters like G, E, etc. So compiler internally generates and adds code below, adds the below code. Integer, myMax, int X, int Y. The compiler will treat this function like the given in the slide. Integer function, if you have given the data type as integer, the parameters will also be considered as int. So compiler internally generates and adds below code. In place of T, character will be added if you give the data type as character, and if you give the data type as integer, then in place of T, integer will be added by the compiler. It will not be shown to the end user, but compiler on its own internally will do the changes and give the result likewise. Function template. Function templates are special functions that can operate with generic types. This allows us to create a function template whose functionality can be adapted to more than one type or class without repeating the entire code for each type. In C++, this can be achieved using template parameters. A template parameter is a special kind of parameter that can be used to pass a type as argument. Just like regular function parameters can be used to pass values to a function, template parameters allow to pass also types to a function. These function templates can use these parameters as if they were any other regular type. The format for declaring function templates with type parameters, template, the class identifier or the type name identifier, and then the function declaration. The only difference between both prototype is the use of either the keyword class or the keyword type name. Its use is indistinct since both expressions have exactly the same meaning and behave exactly the same way. So I hope the syntax of function template is clear to everyone. So in short, function templates are special functions that can operate with generic types. It allows to create the function template whose functionality can be adapted to more than one type or class without repeating the code. So to create a template function that returns the greater one of two objects we could use, I have designed a template by class myType, then myType, then the name of the function getMax, then myType A, myType B. In place of class, you can also write type name. That is exactly the same thing as I have told you before also. So return, if A is greater than B, then return A, else B. Here we have created a template function with myType as its template parameter. This template parameter represents a type that has not yet been specified, but that can be used in the template function as if it were a regular type. As you can see, the function template getMax returns the greater of two parameters of this still undefined type. To use this function template, we use the following format for the function call. Function name, then the type, and then you have to pass the parameters. Type could be int, float, anything. Then you have to pass the parameters according to the type specified in the calling part. So here you can see the example function template. I have created a function getMax and I have used the template name T. While in the calling part, you have to specify what data type you have to pass to getMax. Integer, if I pass, then I have to pass the two values of integer. If it is long, then I have to pass the two long values. Then finally, the result will be calculated. If A is greater than B, then A will be printed. Otherwise, B will be printed. So this is how function template will work. You don't have to specify the data type in the code above. You have to specify the data type at the time of calling the function. So that is why it is known as generic programming. It is a general program. You don't have to write different programs for integer data type, for long data type, for float data type. This is the problem which is being solved by generic programming, in which you have to write one general program, and while calling that particular program, you have to pass the data type. And accordingly, compiler will adjust the template function. Overloading of function template. A template function overloads itself as needed, but we can explicitly overload it too. Overloading a function template means having different set of function templates which differ in their parameter list. You all are already aware of the concept of overloading. Overloading means you have to define the similar function with different parameters and different return types. And the name of the function remains same. So while in case of function template, let's see the example. Template class X, the name of the function is void function. Then the function code is cout, and then whatever is written in the double quotes, it will be printed as it is. Now the second template which I have created is class X and class Y. Void function, this is the function overloading. I have created a function func and I have overloaded this function again. X A comma Y B. Template function code cout inside f x a comma y b. This will be printed as it is. While we call function 1, we have to pass one parameter. In case of function 2, we have to pass two parameters. The name of the function remains same, but the number of parameters differ. In the first function, there is only one parameter. In the second function, there are two parameters. And in the similar fashion, we did function overloading also with normal functions, not with the template type. So if you don't know what function overloading is, kindly refer to previous videos of mine. You will get a clear idea what function overloading is. So try to execute this program and try to see what the output comes on the output screen. Try any compiler and write the code and just check. This is the assignment for you all. Try to check this program and put the result in the comment section below. So today we have studied what generic programming is and what templates are. Templates are used for generic programming. They help in making generic functions and classes, hence achieving the generic codes. So this was very important topic for you all. Generic data types are important in designing libraries that works with any data type. A dynamic binding between data type and data structure occurs at runtime. Generic data types are common in some high-level languages. Generic methods are methods that introduce their own type parameters. Static and non-static generic methods are allowed, as well as generic class constructors. The syntax for a generic method includes a list of type parameters. inside angle brackets, which appears before the method's return type. Let me tell you how you will create a generic class. To create objects of generic class, you have to write the code, the base type, then in the angle brackets type, obj equals to new base type, angle brackets. Inside the angle brackets, you have to write type, then the opening braces and closing braces, small one. In parameter type, we cannot use primitives like int, char, or double. We can also pass multiple type parameters in generic classes. What do you understand by template? What is the literal meaning of template? It is a pattern usually consisting of uh, usually consisting of a model. Template compilation requires the C++ compiler to do more than traditional Unix compilers have done. The C++ compiler must generate object code for template instances on an as needed basis. It might share template instances among separate compilations using a template repository. So this was the summary of today's lecture, the function template, the syntax of class templates, what do you understand by templates, what is the literal meaning of template. Hope you all have understood the lecture. Thank you so much for listening to this lecture. Have a good day.